Hello friends, the topic is percentages and the concept which we'll study is product stability ratio. Let's say we have this product A into B equal to C. Now let's say we want to keep this C constant. Right? If you want to keep this C constant and if we increase this A, we'll have to decrease this B. For example, if I make this A as 2A, right? Then I'll have to make this B as half B so that this 2 will get cancelled with this 2 and we'll get A into B equal to C. Right? So that means I have increased my A by 100 percentages. So if I increase my A by 100%, so I'll have to decrease my B by 50%, that is by half. See here, if B I had B here, now the B has become half B here. Okay, now if I increase my B by half, that means if I increase my A by half, that means my A becomes A plus half A, right? So which is equal to 3 by 2A. So if my A is becoming 3 by 2A, my B has to become 2 by 3B, so that this 3 will cancel this 3 and this 2 will cancel this 2. So if you want to make your B 2 by 3B, then you should decrease your B by 1 minus 2 by 3, that is 1 by 3, right? That means if you increase your A by half or 50%, you will decrease your B by 1 by 3, that is 33.33%. Similarly, if you increase your A by 1/3, that means your A becomes A plus 1/3 A. So that is nothing but 4 by 3A. So if your A is becoming 4 by 3A, so your B will become 4 by 3A into 3 by 4B, so that this 4 will cancel this 4 and this 3 will cancel this 3 and you will get A into B equal to C. That means if you increase your A by 1/3, so you will have to decrease your B by 1/4. Right? Or if you increase your A by 25%, you will have to if you increase your A by 33.33% or 1/3, you will have to decrease your B by 1/4 or 25%. So in general, if you are increasing your A by 1 upon n, will have to decrease your B by 1 upon n plus 1. Right? So B is getting decreased by 1 upon n plus 1. So in general, if we see the pattern, so if you are increasing your A by 100%, that is your A is becoming twice A, then your B will become half B, so that this 2 will cancel with this 2, right? That means you will decrease your B by 50%. Now if you increase your A by 50%, that is by half, then your B will decrease by 1/3. Decrease by 1/3 means decrease by 33.33%. Similarly, if you increase your B by increase your A by 1/3, that means 33.33%, you will decrease your B by 1/4, that is 25%. Now here A is getting increased by 1/4, B is getting decreased by 1/5. A is getting increased by 1/5, B is getting increased by 1/6, B is getting decreased by 1/6. If A increases by 1/6, B will decrease by 1/7. If A increases by 1/7, B will decrease by 1/8. In general, if A increases by 1 upon n, B will decrease by 1 upon n plus 1. Okay, so let's use this concept of product stability in order to solve questions across arithmetic section. So here is a question. Let's say A is 25% more than B, then by how much percentage B is less than A? This product stability concept can be used in a situation where uh, two quantities are inversely proportional to each other, right? Or wherever you see a product, this product stability concept can be used. Now A is 25% more than B, right? That means A is increasing by 25%, or A is increasing by 1/4. So B will have to decrease by 1/5. So if A is increasing by 25%, B will decrease by B will decrease by 20%. Right? That means B is 20% less than A. So again, I'll tell you, if A is increasing by 25%, that means A is increasing by 1 by 4. Right? Then B will decrease by 1 upon n plus 1, that is 1 upon 5. So A is 25% more, it's given 25% means 1 by 4. So that's why B will be 20% less or decrease. Let's say this is a question from profit and loss, and we can apply this concept to this question. The question is, an article is sold for rupees 125 at a profit of 25%. What is the cost price? So the selling price is given. Selling price is equal to rupees 125. Now it's given that we have earned a profit of rupees 25%. That means selling price is equal to cost price plus profit. Now if you see, selling price is 25% more than selling price is 25% more, or selling price is increasing by 25%, right? Then cost price is inversely proportional to selling price, so cost price will be 20% less than selling price, so CP will be 20% less. Selling price is increasing by 25%, so cost price will decrease by 20%. Selling price is increasing by 25%, so cost price will decrease by 20%. By using product stability, it is increasing by 1 by 4. SP is increasing by 1 by 4, so CP will decrease by 1 by 5. So CP will be equal to 1/5 of the SP, that is 125. So which is equal to CP will be 1/5 less than SP. That means CP will be 20% less. So 20% of this 12.5 is nothing but 25. 20% of 125 is equal to 25. So CP will be SP minus 20% of SP. Right. So CP will be 20 SP minus 20% of SP. That is 125 minus 25. That's 100. Right. So CP is equal to 100 rupees. So CP is 20% less. That's why 20% of 125 is 25. So CP will be equal to 125 minus 25. That's rupees 100. Okay, let's see one more question. When the speed of the car is increased by 25%, time taken reduces by 20 minutes in covering a certain distance. What is the actual time taken to cover the same distance by actual speed? So let's apply this product stability ratio or product stability concept to this question. So now speed, we all know, speed into time is equal to distance. So this d is constant here, distance is constant. That means speed and time are inversely proportional to each other. If you increase speed, we'll have to decrease time, right, in order to keep this distance constant. Now it is given that speed is increased by 25%. Speed is increased by 25%. Now, if speed is increasing by 25%, time has to decrease by 20% by using product stability ratio, product stability concept. So 20% of the time is given to us, decreased time is given to us, decreased time is 20 minutes. So 20% of t, that is 20% of original time, is equal to 20 minutes. So original time, that is t, must be equal to 100 minutes. So original time is equal to 100 minutes. So another question again based on time and distances, time, speed, distances, but we'll apply the same concept here. So Unish goes to his office from his home at a speed of 20 km per hour and gets late by 10 minutes. However, when he increases his speed to 25 km per hour, he is 20 minutes early. What is the distance of his office from his home? So what's given here? Initially, when he used to go by 20 kmph, he was 10 minutes late. Now he is increasing his speed to 25 km per hour. He is 20 minutes early. So if you see here, the speed is getting increased by 5 km per hour. That means 5 km per hour speed is increased. So 5 km per hour is nothing but 25% of this 20. Right? So 25% of 20 is 5. So speed is getting increased. Speed is getting increased by 25%. Right? So speed is increasing from 20 to 25, that is 25%. Right? Now if the speed is increasing by 25% and the distance is constant, so time has to decrease by 20% according to product stability. Right? Now decreased time is given to us. Decreased time is, he was 10 minutes early, now he is 20, sorry, he was 10 minutes late and now he is 20 minutes early. Right? That means the difference of time is 30 minutes. Right? So decreased time is 30 minutes. So decreased time is 30 minutes. That is 20% of original time is equal to 30 minutes. Now 20% of the original time is 30 minutes. So therefore original time must be 150 minutes, or 100% of the original time must be 150 minutes. Right? So 20% of the original time is equal to 30 minutes. So original time must be equal to 150 minutes. Okay, so now t is equal to 150 minutes, means 150 by 60 hours, or that's nothing but 3 5 is a 15, 3 2 is a 6, so 5 by 2 hours is the original time. Now we know original speed. Original speed is 20 km per hour. Original time is 5 hours. So distance is equal to 20 original speed into original time. So that's 50 km. So I'll repeat again. Original speed was 20 km per hour. He used to be 10 minutes late. Right? That means if the office time was 11 a.m., he used to reach at 11:10. Now, when he has increased his speed from 20 to 25 km, that means by 25%, he is 20 minutes early. That means now he is reaching at 10:40. He was supposed to reach at 11, but he is reaching at 10:40. So previously he was reaching as 11:10. Now he is reaching as 10:40. That means the time difference is 30 minutes. Time is decreased by 30 minutes. So decreased time is 30 minutes it is given, right? Now, but if the speed is increased by 25% according to product stability, the time has to decrease by 20%. So 20% decreased time is 30 minutes. So 20% of the original time is 30 minutes. So original time must be 150 minutes. That is 5 by 2 hours. So we know the original speed and original time. So distance is equal to original speed into original time. So that is 50 kilometers. Now let's apply the product stability concept to the time and work questions. Efficiency of A is 25% more than B. B takes 20 days to complete a work. How many days will A take to do the same work? Efficiency and days taken to complete a work, they are inversely proportional to each other if the work remains same. Right? Now here, if efficiency of A is 25% more than B, therefore days taken by A will be 20% less than A. Now A is taking 20, less than B. So B is taking 20 days. So B is taking 20 days. That's why A will take 20% less than B. So 20% of 20 is equal to 4. So A will take 4 less days than B. That means A will take 20 minus 4 is equal to 16 days. Let's solve one more question on time and work where we can apply this concept, product stability. 20 men can do some job in 50 days. In how many days will 25 men do the same job? Again, the work is constant. So more men, less days, less men, more days. So number of men and number of days are inversely proportional to each other. That means if you increase men, you will require less days. If you decrease men, you will require more days. So here the men are getting increased from 20 to 25. That means by 25%. Men are increasing by 25%. Number of men are increasing by 25%. So days required should decrease. So days should decrease by 20%. So decreased days is given. So previously we used to take 50 days, right? When there were 20 men, we used to take 50 days. Now days required will be 20% less than 50. So 20% of 50 is 10. Right? So we'll require 10 less days. That means 50 minus 10 equal to 40 days. Men are increasing by 20%, will require 20% less days. Days will decrease by 20%. So 20% of 50 is equal to 10. So we'll require 10 less days than the original days. So 50 minus 10 equal to 40 days will require. Let's apply the concept of product stability to the interest question. So rate of interest is 12.5% per annum at simple interest. What is the principal if amount obtained after 2 years is rupees 1250? So amount after 2 years is given, that is 1250 rupees. So rate of interest is 12.5% per annum. That means rate of interest for 2 years at SI will be 25%. Right? So 25% of the original amount is 12 125% of the original amount is 1250 rupees. So here the amount obtained is increasing by 25%. Amount obtained after 2 years is increasing by 25%. So the original amount, that means principal, must be less than 20% uh, less by 20% than the amount obtained. So amount obtained after 2 years is 25%. So principal must be less than 20% than the amount obtained. So 20% of 1250 is equal to 250, right? So therefore principal must be 12, that is amount obtained, minus the uh, rate of minus the interest, that is 1000 rupees. The next question: due to a price hike of rupees 25%, 5 kg less sugar is available for rupees 100. What is the original price per kg? Now price into consumption is equal to expenditure. Now we want to keep the expenditure constant. So if the price increases, the consumption has to go down or it has to decrease. Now the price is getting increased by 25%. So consumption has to go down by 20% according to product stability. So the consumption now here is getting down by 5 kg because we are getting 5 kg less sugar for the same amount, 100 rupees, right? So decreased consumption is 5 kg, that is 20% consumption, right? 20% consumption, which is decrease, is equal to 5 kg. So therefore original consumption must be equal to increase it by 5 times, so that C will be equal to 25 kg. So the original consumption must be 25 kg. Right? So if the original consumption is 25 kg and original price we are paying for that consumption is rupees 100, right? So the price per kg will be equal to 100 divided by 25, that's rupees 4 per kg. Rupees 4 per kg. That much price we are paying originally. Let's see one more question on the same concept. If length of the rectangle is increased by 25%, by what percentage should the breadth be decreased so that the area remains constant? So area of rectangle is equal to length into breadth. So area is to remain constant. That's why if we increase length, breadth will decrease, right? So now length is increasing by 25%. That means it is increasing by 1/4. So if it is increasing by 1/4, the breadth has to decrease by 1/5. Decreasing by 1/5 means decreasing by 20%. So the breadth has to decrease by 20%. Okay, these are the applications of the concept of product stability. So we can apply this concept, product stability, in various places. Wherever you find the product, and the product, if the product has to remain constant, you can apply this. That means if one quantity is increased, the other quantity will decrease by proportionate amount. Okay? So if one quantity increases by 1 by n, other will decrease by 1 upon n plus 1. Thanks for watching.